welcome to Starship Explorer of the Seas. I predict that it would be about 300 to 400 years, and this is what a spaceship will be like. It'll be very self-contained. We'll be on our way to Mars, and there'll be all the amenities that we're enjoying here on this cruise. So you're sort of the precursors to interplanetary travel, I would predict, in the next few hundred years. My name is Michael Albrecht. Live outside of Austin, Texas. And I know we have people here from all over the world. So I was curious, what's the farthest country we have here? Anybody from Asia? Australia. Very good. Where else do we have? Canada. Utah. The great country of Utah. I'm from the great Republic of Texas, that's right. Yes, very good. Tennessee, great. Well, I've seen people here from countries all over the world. It truly is an international or planetary gathering we have here on this cruise. It's wonderful. So hopefully we'll all interact as much as we can in the time we have while we're having fun. So many topics to talk about. This is the first of 8 shows I'll be doing on this cruise. About 4 of them touch on topics of astronomy. I think they're advertising them as astronomy, but they're all different shows. And then there's several other shows that are not related directly to astronomy. So keep an eye out, and I'm going to try to get a little more detail in the descriptions. So thank you for being here today. We're going to dive on in and talk about astronomy. So here's a Hubble Space Telescope picture of a very small little segment of the Milky Way galaxy, which we inhabit. And each one of these objects in this photo are stars. And it's very important to keep in mind and exciting, exhilarating to me, that each one of these dots is a star, and our sun is basically one of these dots. Our sun is a medium-sized, middle-aged star. And if we were able to travel out of our solar system several light years and look back, we would see our solar system as just one of these dots. Pick any one you want here. And all these little dots are suns. Our sun is a star. So that's a great place to start thinking about astronomy. Another exhilarating fact is that all these objects are moving in relation to each other. This is a static photo, of course, a still photo taken by Hubble. All these stars are moving in relation to each other at very high rates of speed. They're all spinning. They all rotate like Earth rotates and our sun rotates. They're all burning fuel. They all formed inside of nebula, clouds of gases and dust. So every one of these objects you see here formed out of a cloud of largely hydrogen, helium gases and dust. They're burning fuel. They're going to run out of fuel, and they're going to die out. They're going to spread their material around. They're going to have enriched those simple hydrogen, helium elements into heavier and heavier elements, which will allow for the formation of new generations of stars and solar systems, planets, and possibly life. They say a picture is worth 1,000 words. I could almost spend the entire lecture just talking about all the details in this particular photo. But we'll move along here and look at one of these stars. One of those stars being our sun. Very active object. Somebody several years ago came up with a great new name for a star. It's a gravitationally constrained thermonuclear reactor. So if somebody asks you at the bar tonight or wherever, or dinner, what is a gravitationally constrained thermonuclear reactor? You can say it's a star. And that is what it is. And our sun is a very active thermonuclear reactor. Again, it is a It's a middle-aged, medium-sized star. It is burning hydrogen, helium fuel into heavier and heavier elements. It's giving off a lot of material in the form of coronal mass ejections and solar flares. In fact, it just had a major solar flare the other day. Those of you that live at high latitudes in either pole, either hemisphere, the northern or southern, those of you in Australia, you get the southern lights, and up north you get the northern lights. And these solar flares, they throw off material from the sun. It comes and interacts with our atmosphere, basically tickles atoms high in our atmosphere, and that causes those atoms to give off, eject photons, which are the aurora that we know at both poles. So the sun is a very active object. Let's take a look at it in a little bit of motion, a little bit of time motion from a NASA satellite that actually is orbiting the sun and keeping track of it. So out of all those stars we saw in that initial photograph, our sun is one of those stars again. It turns once every 27 days on its axis. It's about 800,000 miles in diameter. 800,000 miles in diameter. Earth, on the other hand, is about 1/100th of that. Earth is 8,000 miles in diameter. So you could fit about 100 Earths across the equator of the sun. So, sun turning once every 27 or so days, 800,000 miles in diameter. It's about 4.5 billion years old. We, astronomers, meaning astrophysicists, believe that it has enough fuel to burn for another 4.5 billion years. So we're okay for the time being. But, as many of you probably know, you're obviously astronomy enthusiasts, that when it runs out of fuel, what's happening right now with the sun is there's two great forces holding it together and trying to push it apart. In the interior are the nuclear fusion processes that are trying to blow it apart, essentially. But gravity is constraining it, as we said with that earlier definition. So we have gravity pulling it in, which helped it originally form. And in the interior, it's trying to push it apart. So there's what's called a dynamic equilibrium. Our sun is very balanced. But when it runs out of fuel in the core, that outward push is going to diminish, and gravity is going to take over the show, and it's going to start collapsing on itself. And when it does that, it's going to heat up again in the core, and then it's going to expand out at a tremendous rate. And we believe that the sun is going to expand out beyond the orbit of Mars. And that's either going to at least boil away the atmosphere and the oceans, or it's actually going to incinerate all the interior planets. So one way or another, we need to get out. We will eventually need to get out of here and find another star or spaceship or whatever. So that's why it's great that we have all this activity in space exploration now. I'm sure many of you watched the liftoff of Elon Musk's SpaceX Starship rocket recently, just a few days ago, and its spectacular end. And NASA is working with other contractors to develop a heavy lift rocket to take us back to the moon, possibly even next year. The Chinese are already planning a lunar base at the south pole of the moon. Chinese are working with the Russians on that. So there's just an incredible amount of activity going on. Wow, that's pretty incredible. I like that. So this is the sun is considered a natural laboratory to study a star. Again, a lot of stars are a lot bigger.